So for direct variation, we need to know the difference between these two graphs. What do you notice about the first graph that doesn't happen in the second graph?
The second one's crossing the origin.
The second one is crossing the origin. When it crosses the origin, it's called a proportional relationship. And we're going to be specifically looking at these proportional relationships today. And I know that you did this last year, so it might be more of a review, or it's brand spanking new, and that's okay too. So linear relationships can be written in slope-intercept form. And if you look at your formula chart, slope-intercept form is y equals mx plus b, where m represents the what? Does anyone remember what that m stood for?
Nope.
Slope. Does anyone think of a second vocabulary word that slope also means? And rate of change. Nice. So slope and rate of change, those mean the same thing. And what does the b represent?
The y-intercept.
The y-intercept. That's why it's called slope-intercept form, because it shows you the slope and the y-intercept. We really like this form of an equation, and specifically today we're talking a very specific version of that. If the y-intercept is any value other than 0, so if you actually have a b there, that linear relationship is called non-proportional. And actually most of the graphs that we did last unit were non-proportional graphs because they all had a y-intercept. Okay, that's this right here. But today we're going to look at these very specifically proportional relationships, which happens when the y-intercept is exactly 0. Again, that's called a proportional relationship. Again, this is something you might have talked about last year. It has everything to do with this equation involving direct variation, y equal to kx, where k is called the constant of variation or proportionality. But I want you to focus mainly on that word proportionality, because today we're going to be setting up and solving proportions to do these direct variation problems. Here's what I want you to notice, and I want you to write this real big. I want you to highlight this. And what we really need out of all of this is how to set up our proportion. And I want you to notice how y is divided by x. You see how y is divided by x because it's in that fraction? 1000% that's what we're going to be doing today. Y divided by x pretty much every single time. Until we get into like word problems and real world scenarios, you're going to see something written like these sentences down here. Whatever the y variable is directly proportional, or whatever the y variable is varies directly. Anytime you see the words directly proportional, I want you to cross them out, and I want you to write divided by. Because again, we want y divided by x. Whatever comes first divided by whatever comes second. Anytime you see the words varies directly, I want you to cross them out, and I also want you to write divided by. That's going to be our helpful hint, and that work has to be shown on every single problem today. Anytime you see varies directly or directly proportional, you're going to write down divided by. Then to solve these problems, all we have to do is set up that proportion that you probably did previously. And there are like 18,000 different methods to solve a proportion. The method that I'm going to show you today, and if you can show me a different method that you use, then that's fine. The method that we're going to use today is called cross multiply and divide, affectionately known as the butterfly method. Does that sound familiar to you at all? Okay. You did it 7th grade? Okay, so yeah, that butterfly method that you did in 7th grade, we're going to bring that back to solve these proportions or to solve these divided by direct variation questions today. Again, if you know of another method that maybe your teachers in middle school taught you, come show me what it is, and I'm totally cool with you using it as long as you let me know what it is, so I know what I'm looking for in your work. What are we going to cross out directly proportional and write? What are we going to write above it every time? Divided by. What are we going to cross out varies directly and write above it? All about divided by today. So let's see some practice problems, because this is really not that difficult. It sounds crazy, but it's really not. So example 1 says, the value of y varies directly with x. Pause already. What do you see right here? Varies directly. What did we say we were going to do with the words varies directly?
Divided by.
All right, everybody do that right now. Cross out varies directly and put divided by. And the reason that we're doing that is because this part right here, that sentence, tells me everything I need to know. It says y is divided by x. Circle the y and the x. And then I want you to write down that y is divided by x. It's going to help me set up my proportions correctly. Now we can finish reading the problem. I'm like, full stop, varies directly, divided by. Okay. It says if x is equal to 2, then y is equal to 12. Should I put the 2 on the top of this fraction or on the bottom? Why the bottom? Because I told you already that it's divided by x, so it should be in the bottom. What number then goes in the top? 12. If x is 2, then y is 12. It then goes on to say, what is the value of x when y is 60? So where do I put that 60?
At the top.
On top. And then what do I put down underneath it?
10.
No.
We don't.
I'm going to put the variable x, because we don't know what that is yet, but we're going to find out using our cross multiply and divide.
Oh yeah. Okay, now I remember this.
Yeah, we've set up our proportion.
Now I remember this.
So what I do to cross multiply and divide is I literally cross multiply 60 times 2. What is 60 times 2? 120. Thank you, calculator or my brain. And then I do 12 times x, which is 12x. In the butterfly method, it's called cross multiply and divide. So what am I going to do next? Divide by. I'm dividing by 12 because I want the x by itself. 10. What is 120 divided by 10?
10.
Yep. Voila, x is equal to 10.
Wait, why is it 120 divided by 10?
What?
120 divided by 12.
120 divided by 12?
Yeah,
You want to get the x by itself. We're trying to figure out what x is equal to.
I got the 120 by doing 60 times 2.
Do you use the exact same number?
I haven't done this in 2 years.
It's been a minute for some of us.
So whatever has x, you use as exact
I had a
same
very
number.
lazy teacher in 8th grade since it was.
So while you're trying number 2, I'm going to get, if you're stuck, I'm going to get you started. It says the value of y is directly proportional. So I see directly proportional. I know to cross that out. And what do I write above directly proportional? Divided by. So we know y is divided by x. Keep going. So since we've figured out that y is divided by x, we know how to set this up. The next sentence says if y is 9 when x is 36, so I label those x's and y's, then what is the value of x, I don't know x, when y is equal to 3? So now we cross multiply and divide. 3 times 36 is 108. 9 times x is 9x. What do I divide by?
9.
Divide by 9, divide by 9. We'd get that 12 is equal to x. Voila, we have solved the direct variation problem.
It's not x equals 12?
That's exactly the same thing, yeah.
Oh, okay.
So you could write 12 equal to x, or you could write x equal to 12. This is literally the math sentence that 12 is x is 12. Those are the same math sentences. Yeah. Questions about number 2 before we move on?
Nope.
Why is the...
Okay, let's check out number 3. It's pretty much exactly the same. It's just a little bit different.
But you don't know that until you...
Hold on one second. It says, what is the value? Oh, wow, that's not what it says. It says, the value of y is directly proportional to the value of x. Pause. What do I do with the words directly proportional?
You divide by.
I cross it out and I say divided by. That's my hint to let me know how to set up this problem. And we know y is divided by x. Okay, so y divided by x. Now I can keep reading. It says when x is 7.5, so 7.5 goes on the bottom since that's x, the value of y is 15. So 15 for the y. It goes on to say, what is the value of y when x is equal to 5? So I'm given a 5 on the x, but I'm not given my y value. Yes, you could make it an x, like technically that's an unknown, but we're solving for y, so let's make it make sense for this problem. We'll put a y up there. Literally changes nothing. If you found x, the answer would be the same, but I need to make sure it was empty on the top. Again, we cross multiply and divide. This would be 7.5y. 15 times 5 is 75. And what am I dividing by?
Wait, what is equal to 75?
5 times 15 is equal to 75.
It is?
Truly, yeah. 5 times 4 is 60. It's an hour. 15 more minutes, that's 75 minutes.
I only know like the first half of the multiples by 15.
Oh man, we gotta learn all of them. Slash, you have a calculator if you don't believe me, but whatever, it's fine. We're gonna divide by 7.5 on both sides, and we get that y is equal to what? 10. That's when a calculator would come in handy. It's y is equal to 10. So the value of y when x is 5 is 10.
Oops, sorry.
All right, you guys try number 4. If you have questions, raise your hand.
Was it the same thing?
All right, I'm going to call in some people to help lead me through this problem. Maya, when you read this question, you see the words varies directly. What do you cross those out and write instead? Yeah, divide by, thank you. And that's going to help me know that I'm dividing y by x. So, phew, set it up correctly. Okay, David, if I'm trying to set up the next sentence, it says if y is equal to 8, then x is equal to 12. Do I put 8 over 12 or 12 over 8?
8 over 12.
8 over 12 because that's the y and that's the x. Very cool. The last sentence says, what is the value of y when x is equal to 9? Mark, where do I put that 9? Do I put it in the top or in the bottom?
The bottom.
The bottom because it's an x, right? Very cool. So we have an empty y spot. That's what we're trying to figure out. So I'm going to cross multiply and then divide. 12 times y is 12y. 9 times 8 is 72. Divide both sides by 12. We'd get y equal to, what is that? 6. Awesome job. Before we move on to the word problems, which are literally the same thing, but just with real-world situations happening, I need one question before we move on. Thank you for your question. Let's move on to our word problems. But we're actually going to do number 7 together. So skip 5 and 6. Y'all will do 5 and 6 on your own. We're going to do 7 because I think it's the most confusing, so I'd rather talk about this one. It says, in an electrical current, the voltage across a resistor is directly proportional to the current running through the resistor. Pause. Whoa. What did we see in there that we needed? Directly proportional. What do we cross the words directly proportional out? Okay, everybody do that right now. So we know exactly what we're dividing by. But before this question, I've been circling the y's and the x because that's what's before and after the words divided by. What comes before the word divided by? The voltage across a resistor. So we're going to put voltage on top. And then it says divided by the current running through the resistor. So it's divided by the current. This one's harder just because we haven't studied electricity yet probably, so like voltage and current may not be that clear for you yet. Does everyone see how I set that up?
Yeah.
Voltage divided by current. Voltage divided by current. Okay, let's keep reading. It says, if a current of 14 amps produces 490 volts across a resistor.
So 14 would be at the bottom.
14 would be at the bottom. Is that true?
Yes.
Very cool. And what would be at the top?
490. Wait.
Adrian, how did you know 14 would go in the bottom?
Because it says current. Current is a current of 14.
It says a current of 14 amps. Yeah, you may not know that amps are a current, but it says a current of 14, and we said current is in the bottom. And then 490 volts, that's voltage, so it goes in the top. Very nice. Okay, we keep reading to hear that it says, how many volts would a current of 3.5 amps produce across an identical resistor? 3.5 goes on the bottom because that's where the current goes, and we don't know the voltage. Yes, we were using y's and x's before, but what letter could we use to stand for voltage? Let's use V for voltage. That way we know what we're talking about. You could totally use X or Y. It doesn't really matter, but V for voltage since that's what we're dealing with. Now that I have this set up, Angel, what am I going to multiply?
490 and 3.5.
490 and 3.5 and?
B, 14. Well, it's 14B, right?
14V. And then can somebody in their calculator help me out? What is 490 times 3.5?
1715.
1715. Okay, Anakin, what's the next step here? What's the last thing I have to do? Divide by?
14.
Absolutely, thank you. So if we divide everybody in their calculator, unless you can do that in your head, but like maybe use a calculator for that one. 1715 divided by 14. Who, say it again?
428.75.
Is that what y'all got? 428.75. Okay, that's the V, but remember this is a real world problem, so we need to put it back into real world terms. What did they ask me for?
The voltage.
The voltage. So we would say 428.75 volts. And that's actually how we would answer this question because it's asking me a real life question. So I have to give you, let's see. Let's see what, let me actually do the math here. I trusted you guys.
That was my fault.
Okay, when we do our math correctly, we erase that. And what did we get again? Sorry. 122.5, which means it's 122.5 volts. I trusted you guys. 1715 divided by 14 should be 122.5. Thank you for checking my mistake. I appreciate it. So here's what we're going to do. You have 3 problems left on this notes page. I want you to try all 3. Okay, I know we skipped 5 and 6, but you're going back and doing those. This one was the hardest one because voltage and current feels like words that we've never seen before. That's okay. Set it up the exact same way. I'll give you about 5 minutes and we'll check our work, okay? As you're working, I'm going to start showing you my work so you can check along with me because I like what I'm seeing around the classroom. All right, my friends, I have them all up here. Don't just copy them. That's super not helpful. Try the problem first and then check your answer with my work. Some of you are setting your proportions up upside down, and as long as you set everything upside down, if you follow your labels, you'll be fine. So if you're labeled backwards, if you put fries over calories, technically that's not how I want you to do it, but you will end up with the same answer as long as you actually put the fries where the fry go and you actually put the calories where the calorie goes. We end up with the same work when we cross multiply and divide. Our second part of our lesson today, our second lesson, it's kind of something different, but it is still a special case of y equals mx plus b. It's not a proportional relationship anymore. It has everything to do with your intercepts. We're talking about horizontal and vertical lines. We're going to need to be able to write equation of a line that is parallel or perpendicular to the x or y axis and talk about if its slope. Okay, so we're talking again about slope and these special cases of y equals mx plus b. What direction is horizontal? Show me with your hands. Everybody, show me with your hands. Horizontal goes like this. Everybody's doing this. Okay, horizontal looks like this. What does vertical look like? Show me with your hands. Yeah, vertical is straight up and down. So everyone right now, I want you to write that above these 2 things. So horizontal, I want you to draw a flat line like this so you remember which one is horizontal. And then vertical, I want you to draw a vertical line. And then I want you to notice that we have an acronym here with those same type of lines. You see this acronym right here? It's called HOY and VUX. That's going to be everything you need to know today, along with the directions that those lines are going. So if you learn one thing today out of the second part of the lesson, I need you to learn what the acronym HOY VUX means. Now, HOY VUX reminds me that horizontal lines, notice that it's written horizontally, horizontal lines have 0 slope, and they cross the y-axis. Their equation is y equals some number. This is what they look like. A horizontal line, they cross the y-axis, they have 0 slope, and their equation is y equal to some number. Specifically the number where it's crossing that y-axis. Easy peasy, that's all the information I need. Has a 0 slope, crosses the y-axis. VUX, on the other hand, stands for vertical lines, have an undefined slope, and their equations are x equals some number. They cross the x-axis. Here's what a vertical line looks like, which y'all have already shown me. It has an equation, x equal to some number. It has an undefined slope, because it's like I'd have to climb it. I can't walk across it. So HOY and VUX are everything that I need to know about horizontal and vertical lines. Some more just pieces of information that we're going to utilize here. Horizontal lines are parallel to something. What does parallel mean? It goes the same direction, right? So what axis goes the same direction as your horizontal line? The x-axis. So it is parallel to the x-axis. Oops, wrong color. Parallel, so it goes the same direction as your x-axis. Oh, no, so we're talking about the first one. Yeah, I jumped back to it. Perpendicular. What does perpendicular mean? That's parallel. Parallel goes the same direction. Perpendicular crosses specifically at a... What kind of angle? Right angle, 90 degrees. There we go. So would you say that the y equals b line here, the red line, crosses at it? That was a terrible 90-degree box marker. What does it cross at a 90-degree angle with? The y-axis. So it's parallel to the x-axis and perpendicular to the y-axis perfectly. Those are Hoy lines. Domain is looking on the graph from the left to the right. So when I look on the left, what do you see on the left side? An arrow, maybe?
So infinity.
And then if you look on the right side, what do you see?
Arrow.
What is it? What do we say when we have arrow to arrow? All real numbers. I heard I'm confused. Where are we confused at? I can answer.
How did you go from wait?
Parallel to?
Yeah.
So this goes the same direction as the x-axis.
Well, why are we talking? Wait, no, I get it.
Okay, are you sure?
Yeah. I didn't see.
So the domain here is from negative infinity to infinity. The double infinities are all real numbers. The range, however, is just the number where it crosses that x-axis. So we would include a list of just the number b, whatever b is.
What does B stand for again?
Your y-intercept. What does b stand for, class? Y-intercept happens every time, especially for Hoy lines. Let's answer these same questions for VUX lines. Vertical lines are parallel to what? They go the same direction as the y-axis, so they're parallel to the y-axis. And they're perpendicular to, or cross at a 90-degree angle with, the x-axis. Now the domain of a VUX line, the only x values that we use, is the number a. It's called the zero of the function, or the x-intercept. That's the a, whatever value it crosses the x-axis at. But if I look at its range, what do you notice at the bottom?
The range.
What's down here?
An arrow.
An arrow. What's up at the top?
An arrow.
What is the arrow to arrow?
All real numbers.
All real numbers. It's going to extend forever downwards and forever upwards, but it only shows up one place on the x-axis. That's the difference in the importance of domain and range. So we're going to pause. We're not going to answer these last questions just yet. Here's something funny. We'll come back to the front at the end, fill out those last things. But here we go. We're going to fill out this entire chart, a bunch of information about each line. I'm going to do the first one with you, and I'm going to leave you and your partners to kind of work through the rest. It's going to be a little difficult until it's not, and then it's going to feel really, really easy. First thing I want you to do is look at this first question. What type of line is this? It's vertical, so we're going to call that a VUX line. I want everybody right now to write down VUX next to this line, because it's VUX. That tells me all of the information I need for a lot of these things. This equation is going to start with what letter? X. Okay, so X is equal to, and we just need to figure out what number X is equal to.
6.
How did you know it was 6?
Because it crosses the...
That's literally where it crosses the x-axis, right? So X is equal to 6. It's at the column labeled 6. So it's at X equal to 6. That's the equation for this line. What's the slope of that line?
Unreadable. 0.
Ooh, it is the U word. What's the U word?
Undefined.
Undefined. Side note, do we know what the word undefined means in math?
It's not known.
It's not, we literally can't do it. Here's what we mean by we literally can't do it. When we talk about slope, we talk about rise over run, correct?
Yes.
Okay, here's the first point and there's the second. How much did I have to rise to get to that point? I had to rise 1, 2, 3, 4, 5. How much did I have to run? Can you divide by 0? You cannot divide by 0. That is literally an undefined number.
Wait.
That's why we say the word undefined for the slope. Yes, all of the vertical lines will have an undefined slope. That is a property of vertical lines, so you can just memorize it. Super easy. We don't have to do the slope every time. We know it's undefined, but that's why.
Wait.
Because you can't divide by 0. What's up? Okay, back to this. Sorry, I digress into slopes a little bit. Let's keep answering the questions here. It says, what is parallel to and perpendicular to? So parallel means the same direction. What is this line? Which axis is this line going the same direction as? Yeah, it's going the same direction as the y-axis, and it's going the complete opposite direction of the x-axis. It's meeting that one at a 90-degree angle. Its domain, we're looking at the graph from left to right when we're talking about domain. Ooh, on the left, does it extend forever to the left and forever to the right? It's just 6. How did you know that, Adrian? Why'd I put B? That's the only place where this graph shows up. It's the x value, or the domain, remember domain is the x's, of 6.
And then it's all real numbers.
All real numbers for the range. Yeah, because the range is the bottom to the top. And if we look at the bottom, or the y values, we've got an arrow, and we've got an arrow at the top, so that one is all real numbers. I want you and your partner or partners to start working on the back of this. And I'm giving you not a lot of information to go on purpose. I want you to try to figure it out. For the second row here, did I give you a graph of it? I gave you the equation. Can you graph it? Can you find the slope? Can you answer all the questions?
Yes.
You got this. I believe in you. Raise your hand if you need help. Try all of them. Okay, thank you for struggling through that. I'm going to start putting the answers up here. I do see some incorrect answers on people's papers, so check when I write it up there. Check and see how you did. Okay, I've got this up here. There were some mistakes on people's papers as I walked around, so check it and see. If you have a question, ask it now. Let's talk about these last 2 questions here. These are the way that they're worded a lot of times on like state tests and stuff. I mean, obviously there will be answer choices. Well, actually, maybe not. There's going to be open-ended questions now. It says, what is the equation of the line with a slope of 0 that passes through 2, 3? What's the important information we should get out of here? What kind of line has a slope of 0? A Hoy line. Okay. So Hoy has a slope of 0, it's horizontal. The equation should be y equals some number. How do we know the number?
Because
We want the y variable, the y coordinate. So it can go through that. The last one says, what is the equation of the line with undefined slope that passes through -1, -4? What's the important word out of that?
undefined slope.
Undefined slope. What kind of line has an undefined slope? A VUX. VUX has a U in it, so it's the undefined slope. Okay, VUX tells me that this equation has to be x equals something. And x is -1, so x equal to -1 is the equation that would graph a vertical line for you in Desmos. Not on your calculator because they're outdated. Okay. Hoy and VUX.